Okay, this problem is a little difficult, can be a little challenging here, but it's meant to illustrate a couple of important points about the chain rule here. And one is we have y is tan of u is v minus 1 over v is ln of x, and we're trying to find out what the derivative of y with respect to x is. So since y is a function of u, we can talk about dy du, the derivative of y with respect to u. And since u is a function of v, we can talk about the derivative of u with respect to v. And since v is a function of x, we can talk about dv dx. And you notice when you multiply all these together that the u's will cancel, the v's will cancel, and we're going to end up with simply dy dx. So what we want to do in this particular case is to find each of the derivatives, or the derivatives of each of those three functions, according to the variables they are defined in. So this is one way to look at this problem. So let's take the derivative of y with respect to u. dy du, derivative of tangent is simply secant square of u. Next, let's take the derivative of u with respect to v. Well, du dv is 1 minus, and 1 over v is the same as v to the negative first. So we're going to bring down the negative 1. So that's going to make this plus. And then it's going to be 1 over v squared. So the derivative of negative 1 over v is going to be positive 1 over v squared. Alright, and finally, the derivative of v with respect to x well, the derivative of ln of x is simply 1 over x. So we can put all three of these together now and say that dy dx is equal to secant square of u times 1 plus 1 over v squared times 1 over x. Now obviously that doesn't help us yet, but it gets us closer to where we want to be. Now we know that we want to evaluate this at x equals 0, at x equals e. So the last part of this is no problem. And so we're going to have 1 over e there. Now v is equal to ln of x, but x is equal to e, so v is really equal to ln of e. And so we're going to get, for the middle term there, 1 plus 1 over ln of e, which is just 1, quantity squared, which again is just 1. And so that whole piece will give us 2. And u is v minus 1 over v. So u will be ln of x, in this case ln of e, which is 1, minus 1 over ln of e, which is 1. So it's 1 minus 1 over 1, and that is simply 0. So we're going to have secant square of 0. And secant square is 1 over cosine square of 0, and cosine of 0 is 1, so that's just going to become 1 there. And we're going to end up with a value of 2 over e, which is option D. Alright, at this point I'm going to do this problem. Hopefully that made some sense there. That way can be a little confusing for some people. Some people may want to view this problem as this. We're just going to work from backwards to forwards and plug in x's. We're not going to use x equals e yet. We're going to plug in v into u and then u into tan u and take the derivative of that whole thing. So y is equal to tangent of u, where tangent is v minus 1 over v. Now, we know that v is equal to ln of x, so y is equal to tangent of ln of x minus 1 over the natural log of x. And so we end up with by plugging v equals natural log of x back into u, and then taking u and plugging that back into y. So now we're ready to take the derivative of this. So y prime, the derivative of tangent, is secant square. We leave the inside alone, and that's the first step of the chain rule. Now we're going to multiply that by the derivative of v minus 1 over v, and the derivative of v and I apologize, we don't have any more v's. We've already gotten rid of them and replaced them with natural log of x's. So now we're looking to multiply secant squared of natural log of x minus 1 over natural log of x with the derivative of that inside function. And the derivative of natural log of x is 1 over x, and the derivative of 1 over natural log of x, we'll take this over to the side and take a look at this. Derivative of 1 over the natural log of x is the same thing as the derivative of natural log of x to the negative 1, and that we'll use the power rule with. So we bring down the negative 1, reduce the exponent by 1, leave the inside alone, and then multiply by the derivative of the inside. Derivative of ln of x is 1 over x. So that is going to simplify down to negative 1 over x times ln square of x. And so, plugging that back in, we have a minus in the original, but because it's minus a negative here, it's going to give us a plus 1 over x ln square of x. And now we're ready to plug in x equals e and see what we get. When we plug in x equals e into the last term, we're going to get 1 over e plus 1 over e times the natural log of e squared, which is just 1 squared. And from this we have 1 over e plus 1 over e, which is going to give us 2 over e. We're going to multiply that by secant squared of natural log of e, which is 1, minus 1 over the natural log of e, which is another 1. And so that's going to give us 0 there. And secant square of 0 times 2 over e. Secant again is 1 over cosine. Cosine of 0 is 1. 1 over 1 squared will still be 1. And so we have 1 times 2 over e, or just 2 over e. And bringing us back to the same answer. So that way was actually a lot more complicated, I think, than doing it the way above. However, the method above can be confusing to some people, even though it can turn out to be a simpler way to solve the problem. Alright, I'm going to stop this at this point here, and hopefully one of these two ways of doing that made sense to you.